AMC12A from 2016. This is question 13. Let n be a positive multiple of 5. One red ball and n green balls are arranged in a line in random order. Let p of n be the probability that at least 3 out of 5 of the green balls are on the same side of the red ball. Observe that p of 5 equals 1, and that p of n approaches 4/5 as n grows large. What is the sum of the digits of the least value of n such that p of n is less than or equal to 321 over 400? And the first time I solved this, I missed that I had to have multiples of 5. That makes it much easier, but you still actually get the same answer. So let's just look at p of 5 and make sure we understand. What happens is we actually have 5 spaces for the green balls, and in between these, in any one of these 6 spots, you could put a red ball. Now if the red ball is here, you can see all 5, so clearly at least 3/5 of the balls are this way. If the red ball is here, 2/5 are here, 3/5 are there. No matter where you put this red ball, you're going to have 3/5 on either side. But when I go to p of 10, so let me give myself 5 more green balls, which gives me 5 more spots, which is now going to be 11 possible places to put the red ball. When I put the red ball here, I'm fine because I clearly have more than 3/5 of the green balls here. But if I put the red ball in this case right in the middle, I have 5 green balls here, 5 green balls here. So at this point here, it does not work. So p of 10 is going to actually be, there are 10 spots for the red ball between the green balls. Only one of them is bad, so it's going to be 10 out of 11. And so we can continue this process, but here is what's actually happening. No matter how many green balls we have, what's the important part is I don't want any red balls to end up inside the middle 5th. There are going to be n over 5 green balls in this middle 5th. If there's a red ball inside here, then it's going to break it. But as long as the red ball is somewhere here or here, then we'll have, let's say the red ball is over here, I'll have this and 2 more 5ths on this side, so I'll have the 3/5. If the red ball ends up over here, I'll have the middle 5th and 2 more 5ths on the left side, so it works. So in here, there are n over 5 green balls in the middle 5th, and if I don't want to place a ball inside there, there are n over 5 minus 1 spaces between there. When n is 10, there are 2 balls here, there's 1 space between them. When n is 20, there would be 4 balls here and 3 spaces between. So this is the number of bad spaces out of n plus 1 total spaces. Again, in this case with 10, I have 11 spaces. The 9 that are between the 10 balls, and then the 2 that are on the very ends. And so this is the probability that we mess up. So 1 minus that probability is the probability that we get a good spot for the red ball, and I want that to be less than 321 over 400. And now I just need to solve this equation. So what I did is I added this to both sides and subtracted that from both sides. 1 minus 321 over 400 is 79 over 400. That has to be less than, and when I add this to both sides, I get n over 5 minus 1 over n plus 1. All right, bring this work up here. I'm going to cross multiply both sides by 400, multiply both sides by n plus 1, and I will get 79n plus 79 must be less than 400 times n over 5 is 80n minus 400. And now I'm going to add 400 to both sides and get 479. And subtract 79n from both sides and get 1n. So n must be bigger than 479. The first integer bigger than 479 is 480. And 4 plus 8 plus 0, because we want the sum of the digits, is 12. Feel free to comment with questions down below.